Welcome to the Wago programming tutorial. In this session, what we're going to cover is the basic startup of a Codesys project from the very beginning. So in this, we're going to do a basic ladder program, setup of the node, pointing variable names to hardware addresses, things of that nature. So to get started, what we need to do is first come in here and select the new project over here icon, or you can also do a file and then new from here as well. Either way, doesn't matter, get the same point. So once the project starts anew, one of the first things we have to do is select the actual controller that we're going to be programming. In this case, it's going to be the 750-880. So we'll scroll down the menu list here looking for the 880. And then we have various things in here that we can set up with regards to enabling the load boot project automatically, online changes, disabling PLC and trace, PLC browser and trace functions, network functionality, visualizations, creating a web page, and things of that nature. We're not going to do anything with these just yet. The primary focus of this exercise is just getting started with a basic project. So we're going to say OK once we've selected the controller. Now, once we've done that, the first thing Codesys is going to prompt you to do is create a new POU. The main routine for all Codesys projects is the PLC_PRG. And here we can select the type of POU, whether it's a program, function block, or function. We will be creating function blocks and functions later. Again, at this point, we're just going to create a basic ladder program to get started within Codesys. So over here, we've selected ladder as our language, and of course, you've got instruction list, function block diagram, sequential function charts, structured text, continuous function charts to choose from. We're going to use LD for ladder. I'm going to say OK. All right, now from here, of course, we could just start writing our code and creating our project. But in this case, again, what we want to do is create a PLC configuration of the node we're actually going to be working with. So I'm going to come down to this Resources tab, and I'm going to click on this PLC configuration. And this hardware configuration opens up, and I can expand that another level to show K-bus, field bus variables, flag variables, and so forth. Now, from this point, we can just right-key click on the K-bus and select append sub-element. Okay, now we can go into the configuration setup. There's a couple of different ways we can do this. We can open up IO check from here, scan the node, and pull that information in. We can go to this open configuration file from a specific folder location, and if you've gone through the IO check tutorial, or if you've used IO check before, you know that you can create the XML file within IO check, and that can be imported or pulled into here for your configuration. We're going to go through the manual setup so you can see how to do that as well. So I'm going to come over here, select this add button, and then this window opens here. And I can do this a couple of different ways as well. I can come in and expand the folders here, open those up, and look at the various I/O modules in there, digital, analog, specialty modules, serial interfaces, and so forth, and just pull them in from there. I can also just come up here and type in the various I/O modules that are actually in my configuration. So we can come in here, type in a part number, select the device, and then drop it into this window here for the configuration. And of course, we can also, like I said, just type in the other part numbers while we're at it. Again, I'm looking here specifically for the 75467 in this configuration. Select the module, and again, drop it right into there. All right, and then one more, the 550 analog output module. And I'm going to select that and drop it in. Okay, and here's my node configuration. Fairly simple, but again, you could do this for however many number of cards you have in your I/O structure, and of course the other options with regards to pulling in the XML file and using I/O check through Codesys are other very good options as well. One thing that of course that's important is the actual layout that you've created here. Configuration file has to match, of course, the physical orientation of the node itself. If you placed a module in here and you needed to move it around, you don't have to remove, replace, and go through the whole process again. You could just simply come over here and use these up and down arrows and move the module within the configuration file itself. Another thing that we can do, especially for people in the field from this standpoint as well, is if you're in the field, maybe you don't have internet access, you don't have catalogs or data with you that's pertinent to this various cards you're going to be working with, or if there's field changes, you may need data for it. You can actually select the card, come over to this PDF button, select data sheets, and now you get a full cut sheet in PDF format for the module. So things like current consumption, how to wire up the device, and things of that nature can be shown or seen within this PDF file. So again, just the different things that you can do within Codesys. And so now you can see this PDF here, and then you can get the data from it. Okay. So another thing that you can do, of course, while you're in here is you can point your variable names to the hardware addresses themselves. So in here, I'm just going to put some very simple input and output variable names. You want to be a little careful here when you're using like the 8 in, 8 out card, because if you notice, the input-output structure here is alternating. They're not grouped inputs and outputs separated from one another. Again, they're alternating. So again, I'm just going to put in a couple variable names here for this project. Okay. And then from here, I can change different things in here, like make some comment lines about its specific function and things like that. All right. So from this standpoint, we're pretty much finished. Just say OK. And now if we come over to the K bus and expand it another level, we can see the various I/O cards, and now you can see the variable names pointing to specific hardware addresses. And of course, we could do this with the analogs and other signals as well. All right, once we're finished here, we can now go back to our POU section, and we're going to select our main routine. And now from here, we can actually start writing our code. In this case, again, it's going to be a ladder project. So unlike some programming tools, you don't have to click and drag. It's just a matter of getting on or selecting the correct rung and then selecting what you want to drop in there. For example, here, normally open contact, and then you can see it's dropped in. Now I can select the question marks, use F2, and now I can look for, or use my input assistant to allow me to look for the various variables that I've already declared, for instance. I have listings for local variables, which would be just within the specific POU. Global variables, those would be anything that's defined as a global variable, either in the global variables list, or also any variable that's defined in the PLC config is also automatically considered a global variable. And then, of course, we have the system variables. This would just be the hardware address variables, if you will. So you can see they're listed in both. It doesn't matter which one you select. They're the same. Also, the variables are not case sensitive. So if I use a lowercase input 1 and an uppercase input 1, they will look the same. We can also use underscore and stuff like that for variable names. Next, what I'm going to do is just drop in another contact here, negated or normally closed. Again, I'm going to use F2 and use input 2. All right. And lastly, I'm going to drop in a coil, F2, and output 1. Now, just as a side note here, you can also use direct addressing. You don't have to use variable names. So for example, for input 1, if I want to put %ix 2.0, I could do that as well here. I do not have to use the variable name. All right, I can also come in here and display additional information. So if I come into extras and options, I can come down into this configuration and do things like show address of symbol or variable comments. So you'll see now this has changed. I have the address in here and then the comments that are pulled in as well, pointing to information regarding the variables that are being implemented in this rung. All right, so from here I'm going to click on the first rung. Now I'm going to right key click, do a network after, and now you can see the next rung is dropped in. And now I'm going to right key click in here, and I can either insert box with enable from here, or also can come up to the menu up top or the buttons on the top and select box with enable as well. Both the same function. You see the AND function is dropped in by default into the rung. And there's a couple of ways I can get into this. I can select AND here and hit F2, and then I can look for either user-defined functions, standard functions, function blocks, conversion operators, all different things. In this case, I'm looking for a standard function block, and you can see here I'm going to just drop in a timer on delay. Now, because it is a function block, I do have to declare an instance of it. And I will do that now, and the auto declare window pops up. You can see here it knows it's a timer on delay. And okay, and I can also come up here and view the local declarations now, because T1 is considered a local variable. And in here, select the input, what's going to trigger or toggle the input on the timer on delay. Now in here I can put in a variable name. I can also just put in T#5S for the time value that I want to use, in this case 5 seconds. Unlike some other programming tools that you may have used in the past, we do not just have increments of milliseconds. You can see here now I have 5.5 seconds, so we can go milliseconds, seconds, minutes, and so forth as far as what our base of time is. Again, we're not just stuck with the the milliseconds as our time base. So now here I'm going to just put in a new variable, and you can see it's a Boolean, a T1 done on the output. Again, this is being declared up here, and then one last variable to put in here, our T1 elapsed time. Now you want to be careful with some of these function blocks because you can see here this is a time value. This ET elapsed time is, but by default it comes up as a Boolean. You can type it in here, time, or you can use the pull-down menu for a list and select time. Either way you want to do that, again, you get the same results. Say OK. And now, one other thing with this, if you're looking at a function block, again, timer on delay is fairly straightforward, but if I'm looking at a function block and I'm curious as to what the inputs and outputs are, what are their values as far as, or I should say data types, I could also come into here with the pre-written libraries within Codesys, for example, come into my library manager under the resources tab, and then I could look for the actual function block, in this case the timer on delay, and then in here I have a comment line that describes exactly what the timer on delay does, its functionality, the various inputs and outputs, what are their data types, and what is their function within the function block as well. So that information for the library files may be in here that you can reference if you want to know exactly how it works or functions. I'm going to come back to the main routine again just to show you that. Now I'm going to right key click, again network after, and now I should see my next rung here. Again, I'm going to put a box with enable in. I'm going to select the AND again, as I mentioned earlier, it's the default. But this time I'm just going to type it in. I'm not going to use F2. I'm just going to put a counter up function block in here. And now, of course, I need to declare an instance of this as well because it is a function block. Again, CTU comes up by default. And now I can put in here the trigger for the incrementing of the counter. In this case, I'm going to look for a local variable, which is our T1 done. And OK. In here, I'm just going to add a variable. Again, it is a Boolean in this case, so I can just say OK. Preset value, this again could be a variable I'm going to declare, but in this case I'm just going to put a fixed integer value in there. Again, I could put a variable that I write to via an HMI or whatever the case may be, or even the visualizations within Codesys. Now C1 done on the output. Again, this is the Boolean. When our count value is reached, then we will set this high. And then the actual count value will be displayed here. And again, you'll see in some of these, again, it's going to come up by default as a Boolean. This is not a Boolean. In this case, it is a word. And then I'll say OK. If for some reason you had something that was declared incorrectly, a couple of ways again to address that. You could just highlight or type over. Let's say it was Boolean here, I could type in now word over that. I can also, maybe there's something more I want to do this, maybe I want to point it to a memory location, set it as retain or whatever. I can also hit Shift F2, and now you can see the auto declare window pops back up. I can set an initialized value, pointing to a memory location, change its class, and then you can see retain persistence and comments and things like that I can put in as well. Okay. And either way will correct that. I'm going to right key click network after. And now I want to put in a new rung, but something I've created already is very similar to what I want to do in here. So instead of starting all over again and recreating this rung from scratch, what I can do is come to a previous rung and select it and do a copy. And you can use the shortcut keys and all that as well. And then come down and paste that into this rung. Now this is most of what I'm looking for, but not exactly what I want to do, so I'm going to modify it slightly. I'm going to come in and select the normally open contact, and then hold down the Shift key and select the normally close. So you can see this box is formed around both sets of contacts here. And now what I want to do is drop in a parallel contact. So I come up to this top menu bar here, select the parallel contact, and now that is dropped in around those two. And again, I can use F2, select C1 done in this case, and then I can come over here, and I can either use F2 or in this case I could just edit this to output 2, as you can see there. Then lastly here, I'm going to put in one last rung, box with enable. This is going to be a GT greater than. It could be LT less than, EQ equals 2, GE is greater than or equals 2, for example. So there are all kinds of standard operators and functions in here. They're listed in Codesys as well, so you can look those up. So on the input side here, when C1 value is greater than, and again, I'm going to just set a value here, but of course we could put another variable name in. Then my resulting output is going to be our count reset. And now you can see this is complete. Now the next thing I want to do is rebuild the project or build it one way or the other, just to confirm there's no errors or warnings. So I can see down here in my message window, I have 0 errors, 0 warnings. Of course, that's what I'd like to see in my project. So now we want to, again, connect to the controller to test the program. We could also just run this in simulation mode. So we could go online here on the pull-down menu, select simulation mode, and then it would be as if you were just logging into a controller. So I could select simulation mode, go to login, in here, and then once I log in, then I'm going to hit F5 and it'll run and start the program running on the laptop itself. But in this case, what we want to do is actually create or connect to a Wago device. So we're going to create a new communication channel. So I would come in here, open this communication parameters, go to new, and now we could just name this 192.168.1.2 for the device. Select the TCP IP driver here, third one from the bottom. We can also use the serial interface to 232 because we can interface to the controller via the port on the front, the serial port, with either a D-sub connector or the USB cable. In this case, we are going to use Ethernet. We could call it turntable 2, configure 4, whatever we want here, depending upon its function within the system, for example. In this case, again, I'm going to use the IP address that we're going to connect with. Now, from here, I have to click into this box here, and now I can enter the actual value of the IP address. Previously, all I did was name it, so I didn't actually put the IP address in. So here, I'm going to put the IP address in for the actual device. I want to be careful here. I can either hit enter or click off the box here, like so, the content field, if you will, to make sure that it's accepted the change. If that is still open, like so, and I select cancel, or OK, I should say at this point, it'll go back to localhost. So want to make sure that I close that and then select OK. Now from here, I can go online and log in, and immediately I should see a box here that says something, either the program's changed or there's no program on the controller. That lets me know that I've actually connected to the device. I can say yes here. And now it's going to begin the download of the project to the controller. I can see down here I've connected to the device. However, I'm not running yet. I can use the online run or F5 key just on the keyboard, and now the program is actually running on the controller. And you can see we can look at the inputs, outputs, and what's going on within the actual program or routine. I'm going to turn on input 1. Toggle the input, and now I can see my elapsed time is starting to increment here. T1 done just went true, and scrolling down I can see now that the count value is incremented by 1, and then output 2 here is actually on as well. Just going to minimize this a little bit so we can see it's a little bit easier. All right, and excuse me. Then we can also do, just to kind of help it from a visual standpoint, I'm going to just uncheck these boxes so we can see the actual code running. Of course, you could go up and down on the screen with no problem with that. And you can just see now, again, a little bit more of the routine running. Toggle input 1. Again, it's going to start my timer on delay, and then my count value will increment once T1 done is true. Once more. And now my C1 value is on 3. And you can see now C1 done is true. Now no matter what I do on input 1, my output 2 is latched high until that count on the counter up is increments above the 3 because of the greater than I put here, and we'll set that reset and set our count value to 0. So if we let this cycle through, then our count will reset because our greater than down here, and now output 2 will go off. And there's different things we can do. If I was, for example, again, if I make this a little bit larger and I'm working or troubleshooting or debugging something, and maybe I'm down lower in the routine and I'm looking at maybe my counts or my greater than or whatever, and I needed to view also the timer from up above, then what I can do is pull this down a little bit, look for my T1 done, expand it, and then I can actually see what's being executed or running within the timer while I'm down on maybe a different rung and watching the execution of some other things that are going on with regards to output 2, my counter, my greater than, and so forth. Okay. You can also, of course, come back to the PLC config, and you can also view the action of the inputs and outputs here as well, just so you know. Okay. All right, so this was just basically getting started with a project within Codesys, loading the program on the controller and watching it execute at this point. And this is, again, just to help you get started within Codesys and working with the tool. Hopefully you found this useful. Please take the time to view some of our other programming tutorials. We have this project will be posted as well in different languages with regards to structured text and function block diagram as well. And you can see that. And also we have some for other things like programming PIDs, IO check, usage, and things of that nature. So thanks again for your time, and again, visit Wago YouTube to see other videos. Have a great day.